Ladies and gentlemen, this is the general ability portion of the Electrical Engineering EE department of 2022. Let's go through the following questions. So this is the first one. As you grow older, an injury to your dash may take longer to dash. So injury to your body part, that is heel, has a spelling of my apologies, just hold on a second, has a spelling of HEEL and may take longer to heal, means cure, has a spelling of HEAL. So I hope you can realize that it is going to be option number D. Let's go on to the next question. In a 500-meter race, P and Q have speeds in the ratio of 3:4. Q starts the race when P has already covered 140 meters. What is the distance between P and Q in meters when P wins the race? So when the race starts, it's somewhat like this, that P has already covered some distance, which is 140 meters. And at that point of time, Q starts. So the race begins with the speed of P and the speed of Q being of the ratio 3:4. So we can take the speed of P as 3k and that of Q as 4k. So this is what happens. And after the race, P wins, means P is now here, and obviously Q is some distance behind, because if Q had been in the beginning, then Q would have won. So P wins, so Q must be some distance behind. So this is the finishing part. They have asked us what is this distance. So how do we find it out? Very simple. The total race is 500 meters. So when Q started, the distance P had left to cover was 500 minus 140. That would be 360 meters. Now, what was the time taken by P to cover those 360 meters? It would be 360 divided by the speed of P, which would be 120 by k units. But then Q from the start till this position where it is at the end of the race must have run for this time only. So what is the distance covered by Q? That would be the time into the speed of Q, and that comes out to 480 meters. So P has covered 500, whereas Q has covered only 480. So this portion must be 500 minus 480. That is equal to 20 meters, which is our correct option. Let's go to the next one. Three bells PQR are rung periodically in a school. P is rung every 20 minutes, Q is rung every 30 minutes, and R is rung every 50 minutes. If all the three bells are rung at 12 p.m., when will the three bells ring together again the next time? Now, to find in such a case the interval, the time interval after which all the bells will ring together, that will be given by the LCM of the three times, that is 20, 30 and 50 minutes. Now what would be the LCM of this? 10 is common, 2, 3 and 5 are left, so 3 2s are 6, 6 5s are 30, 30 into 10 is 300. So the LCM is 300 minutes. That is equal to 5 hours. So after a time interval of 5 hours from the time that they rung together, the second time they will ring. They will all three ring together. So since it rung together at 12 p.m., so the next ringing will take place 5 hours after 12 p.m. That is at 5 p.m. So that would be our answer. Let's go to the next. These are syllogism problems. Given below are two statements and four conclusions based on the statements. So statement number one says some bottles are cups. So how can we represent these in terms of a Venn diagram? See, some bottles are cups, where B stands for bottles and C stands for cups. Well, some bottles are cups could also be this. See, and since in syllogism, some can also assume the value of 100%. So some bottles are cups can also be this one. So these are the three different forms that some bottles or cups can assume when expressed in terms of Venn diagrams. Let us go to statement 2. Statement 2. All cups are knives. So all cups are knives would be somewhat like this. See, all cups are knives, where K stands for knives and C for cups. And then all cups are knives could also be this. These are the only two possibilities by which you can express statement number 2 in front via a Venn diagram. Now let us look at the conclusions. Conclusion number 1 says some bottles are knives. So they have compared bottles from statement 1 to knives from statement 2. So here I will be forced to punch both of these together. So how will I select? I can select 1A and 2A. I can select 1A and 2B. I can select 1B and 2A. I can also select 1B and 2B. And of course, I can also select 1B, rather 1C and 2A, and also 1C and 2B. But then we can clearly notice that C and B don't influence any difference, don't induce any difference between the combinations. So anything involving 1C and 2B, we can very easily cancel it out. So 1C and 2B, this we can cancel. See, 2B is there, we can cancel. Here also 2B is there, we can cancel. And here 1C is there, we can cancel. So these two are important. We must see them. Now what happens if we combine 1A and 2A? If we combine 1A and 2A, the diagram would be somewhat sort of this. See, these are bottles. See, I have got 1A is in there, and these are knives. What has been said? Some bottles are knives. This is absolutely true. Some bottles will definitely be knives. At least the bottle part that is contained by cups will definitely be knives. So this is always true in this. Now let us look here also. 1B and 2A. So 1B and 2A, how is it? See, this is cups and knives as expressed in 2A. And then there is bottles. So that will be somewhat like this. So obviously this portion minimum of knives must always be bottles. So this is also true here. So when both of them show the truth, I will say that this conclusion must definitely be correct. So this is correct. Now let us look at the other conclusions. So the next one says some knives are cups. Now cups and knives are in the same part. So we can look at this. See, some knives are cups will always be true, because mind it, some can also be 100%. So that is being followed in the 2b, and this is actually true. So we will say conclusion 2 is also correct. Let us now go to conclusion 3. All cups are bottles. So you see here, cups and bottles, they are in the same statement. So if we look at statement 1, it will be okay. So all cups are bottles. This is absolutely true here. All cups are bottles. But is this true here? No. All cups are not bottles. So we need not research for the next. If one is untrue, then we will say that this is incorrect. Last one, all knives are cups. So we will say, you see, knives and cups. So they are in the same statement 2. All knives are cups. This is absolutely false here. All knives are not cups. So we need not look at the next. If one is wrong, then this is incorrect. So which of the following options can be logically inferred? We will say conclusion 1 and 2 can be logically inferred. And you see, this must be option number A. Next, the figure below shows the front and rear view of a disk which is shaded with identical patterns. The disk is flipped once with respect to any one of the fixed axes 1, 1, 2, 2, or 3, 3, chosen uniformly at random. What is the probability that the disk does not retain the same front and rear views after the flipping operation? So now, see, the examiner himself or herself has showed us that, see, look at the front view, and we flip it on 1, 1 axis. Don't you think we will be getting this? See, this portion has spatially gone on to form this, and this portion has spatially gone on to form this. So I hope you can understand that this itself is the flipping along the 1, 1 axis, and hence we can say that along the 1, 1 axis, both the rear and the front view are the same. Now let us try flipping along the 2, 2 axis. So if we flip along the 2, 2 axis, let us write it down here. See, this is the 2, 2 axis. We are flipping around here. So how do we do this? See, the original scenario is this. Now, because we are flipping this, so this portion would now be on this part. This portion would now be on this part, and this total together, this thing would now be on this part. So we can definitely see that the rear doesn't agree with the front. So we will say 2, 2. It will be different. Now let us flip along 3, 3. So let us do it here. Let us flip it along 3, 3. So we are flipping along 3, 3. So if you do that, then this portion would now become, the shading would come up here. This portion, the shading would come up here on this side, on this side, and this portion, the shading would have come up on this side, and we can see that it definitely does not agree with the front view. So we will say that 3 is also different. Now there are 3 cases, possible cases, out of which 2 cases are favorable for us. That is, it does not retain the same front and rear views. So we will say that the probability would be 2 out of 3. So this is our answer, 2 by 3. So probability expressed via a logical reasoning problem. Let's go on to the next one. This is a critical reasoning problem, and critical reasoning does test the vocabulary of a student. Altruism is the human concern for the well-being of others. So the examiner has himself or herself told us what is the meaning of altruism. Altruism has been shown to be motivated more by social bonding, familiarity, and identification of belongingness to a group. I hope this is understood. The notion means idea. The idea that altruism may be attributed to empathy. Empathy means feeling pity, okay, or guilt has now been rejected. So that is the passage. I am sure, ladies and gentlemen, you understand the fact that in any critical reasoning question, whatever is said in the passage, even if it practically might not be true, will always be true for us as long as we are solving that critical reasoning. We cannot bring in our own judgment, or we cannot, give other facts than what is given in the passage. So this is something we must understand. So for us, this passage is what is true for us. Which of the following is the correct logical inference based on the information in the above passage? Let us check. Humans engage in altruism due to guilt but not empathy. This is absolutely wrong, because if you see, it has been said altruism, the attribution to empathy as well as guilt, both have now been rejected. Okay, so here it has been said that due to guilt it happens, so that is wrong. The second, humans engage in altruism due to empathy but not guilt. Again, this is wrong, because due to empathy would be the wrong one here. So that is wrong. Humans engage in altruism due to group identification but not empathy. Now they engage in altruism due to group identification. C is absolutely correct here. And not empathy is also absolutely correct here, because such has been mentioned. So we will say that this is the correct conclusion that can be drawn. Inference means conclusion. Okay. And the last one, obviously there can be only one correct answer, but since this is an explanation portion, so I am dealing with the last one also. Humans engage in altruism due to empathy, which is again the wrong one. So this one will also be wrong. So hence option C will be the correct one for us. Let's go on to the next one. There are 2 identical dice with a single letter on each of the faces. Each die will have 6 faces. So hence the following 6 letters starting from Q, Q, R, S, T, U, V is present in one of the faces. They have said that any of the 6 outcomes are equally likely. The 2 dice are thrown once independently at random. What is the probability that the outcomes on the dice were composed only of any combination of the following possible outcomes, Q, U, and V? The gist of the matter is that, see, each die has those 6 letters Q to V. Now you are throwing 2 die, independently and at random. What is the probability that Q, U, or V will appear on the die? That's what they have asked. So how are we going to solve this? To solve this, the first thing that must come in our mind is that 2 independent cases might occur. One independent case is, see, these are both the die. On one, suppose X shows, while on the other a different alphabet shows X and Y. This can be the case. And there can be a second case also. See, you throw both the die, and what happens is, if X shows here, X also shows here. So both show the same alphabet. Both of these cases can happen, and both are independent, so we consider them separately. Now we must also understand one thing, that because these 2 die are independent, the throwing of these 2 die are independent of each other. So X falling on the first and Y falling on the second, and Y falling on the first and X falling on the second are 2 different cases, right? You must understand that also. Now, any probability is always nothing but a ratio of the favorable outcomes to the total possible number of outcomes, which is also known as sample space, is the ratio. So let us find first what is the total outcomes. Now first let us take this case. There are 6 alphabets, out of which 2 should fall. So 62. And those 2 that will fall, if they are interchanged, they form a separate combination. So their number of ways of arrangement is factorial 2. Now for this case, see, out of the 6 alphabets, only 1 alphabet will fall. See, it will fall on both. Now here, X here, and the reverse will create the same combination. So no cases of arrangement. So these are the 2 different cases. Now these are independent, so you will have to add them up. So we add them. What is the result? 6C2 is 6 into 5 divided by factorial 2, which is 3 into 5, that is 15. 15 into factorial 2 would be 30 plus 6, so the result would be 36. Now let us consider the favorable outcomes. Now we must not forget that the favorable outcomes will be out of Q, U, and V, that is only 3 letters. So out of those 3 letters, 2 might fall. See, this is the case. 2 will fall, and they will have a different arrangement if reversed. Now the second case, from here, this can also be possible, that out of the 3 letters, any one will fall on both. These 2 are independent happenings, so we can add them. We will add them. 3C2 is 3, 3 into 2 is 6, 6 plus 3 is 9. So the probability would be 9 by 36. So that would be 1 by 4. And the first option itself is 1 by 4. And this is a fantastic problem. Okay, I hope this is understood. Let us go on to the next. the price of an item is 10% cheaper in an online store S compared to the price at another online store N. Store S charges rupees 150 for delivery. There are no delivery charges for orders from the store M. A person bought the items from the store S and saved rupees 100. What is the price of the item at the online store S? If there are no other charges, then what is described as? So what has been said here? Say suppose there is a store M, and let us suppose that the price at M is of the commodity of the item is 100x. This is the price. Then what is the price at store S? 90% of 100x, because it is 10% cheaper, which is 90x. So that is the price. But then store S charges 150 rupees for delivery. So this is delivery charge, which is not charged by N. So for the customer, the total payment to be made if purchased from S is 90x plus 150. Whereas if purchased from M is only 100x. In spite of that, it is found that had the person bought it from S, he would have saved 100. So I can say that 100x minus 90x plus 150 must be equal to rupees 100. So just on solving that, 10x equal to 250. They have asked me the price of the online store S. Means they have asked me about 90x. So that must be 250 into 9. That is equal to rupees 2250, which is the option B here. Hope that is understood. Let's go to the next one. The letters P, Q, R, S, T, and U are to be placed one per vertex on a regular convex hexagon. I'm sure we all understand what a convex hexagon is. Regular convex hexagon means all the sides of that convex hexagon are equal, but not in the necessarily in the same order. So P, Q, R, S, T, and U will not fall necessarily in the same order. Consider the following statements. The line segment joining R and S is longer than the line segment joining P and Q. Two cases can be possible, but the challenging part is drawing the hexagon. So we are trying here. Might not exactly be 100% regular, but I presume it is understandable. So this is a regular hexagon, assume it. So R and S is longer than the line segment P and Q. So it can jolly well be possible that, say suppose this is R and S and this is P and Q. Because if such were the case, the criteria was fulfilled. But likewise, this could also have been the case. Another hexagon. See, here R and S, we can take this largest possible side and say P and Q can be this. So you see R and S is greater than P and Q. In both the cases, it is true. So we have dealt with the first one. Now the next one. The line segment joining R and S is perpendicular to the line segment joining P and Q. But in this diagram, that is not happening. So this diagram gets cancelled. But here, as you can see, this is perfectly all right. It is perpendicular. So this diagram stays. So this is done. The next, the line segment joining R and U is parallel to the line segment joining P and Q. Very cleanly it can be seen. If U were here and P were here, then the criteria was fulfilled, because indeed TQ is parallel to RU, right? So from these three, we have hit upon the correct combination, and we can say that our hexagon is nothing but hexagon PTRUQS. So this is the hexagon. Let us now observe what has been asked. Based on the above statements, which one of the following options is correct? The line segment joining R and T is parallel to the line segment joining Q and S. Absolutely correct, because it is indeed so. R and T, just hold on. R and T, the line segment joining R and T, is indeed parallel to the line segment joining Q and S. So that is definitely true. Next, the line segment joining T and Q is parallel to P and U. T and Q is parallel to P and U. It is definitely not so. I hope we can understand. So this is not true. Though of course only one option will be correct, but since this is an explanation session, so I'm going through all of them. In the exam hall, the moment you have found this out, forget the others, save time. The line segment joining R and P is perpendicular to the line segment joining U and Q, which is absolutely wrong. The line segment joining Q and S is perpendicular to the line segment joining R and P. So Q and S and R and P, they are perpendicular, is also wrong. So this stands correct. I hope we have understood it. Next. An ant is at the bottom left corner of a grid at point P. So the ant is here, as shown above. This is a 4x4 grid, as you can see. It aims to move to the top right corner of the grid. So it will move here. The ant moves only along the lines marked in the grid, such that the current distance to the top right corner strictly decreases. Which one of the following is a part of a possible trajectory of the ant during the movement? Now, naturally, if the ant moved this is, one can understand. See, this is key. So it moves here, then again comes back, then again goes back and does this. So obviously, once it moved here, the distance increased, right? If it had thought of taking this, if it had thought of coming back again. So obviously A won't be. Here, again the ant thought of going here and then again coming back. So the moment the ant reached here, his distance increased because his trajectory was now this. The ant thought of coming back. Now here the ant will move around in circles. So this doesn't happen, he will never reach here. The only way it is absolutely correct is this. See, the ant is never going back. And like this, if he moves another one, he will reach another two to be precise. He will reach at the top. So naturally, it would be option C. Next, that is the last one. So that's it, ladies and gentlemen. Thank you very much. Hope this portion is clear to you.